let's give you guys some more practice on finding out all the factors for any given number. So in order to do this, try to remember all as many primes as you can. At least remember these ones. Okay. So here, given this number here, find out all the factors for this number here. Now, even though the question is saying find out all the factors, you can translate this problem as writing this number as a product of primes. So even though I'm asking you list all the factors for this number, but answer that question by doing this. Express this number as a product of primes. Okay, prime 1 times prime 2 times prime 3 and so on. Well, even though I'm asking you list all the factors for this number, forget about that and visualize the problem as this. Express this number as a product of primes. Now, once you've written it in this form here, you can work out all the factors once you're in this product of primes. So you can start combining these two, maybe these two, and so on. So even though I'm asking you list all the factors, what you should be doing is write this number as a product of primes. Okay, so press pause and have a go. Okay, so let's try and write this problem as a product of primes. So here, this 4 here is an even number, so I know I can divide by 2. Okay, so I'm going to visualize this as 2 times something. Let's work out that something. So 1764 divided by 2. That would be 17 divided by 2 without going over would be 8. Remainder 1. 16 divided by 2 would be 8. 4 divided by 2 would be 2. So I can visualize 1764 as 2 times 8, 8, 2. Now this thing here is an even number again. So I can visualize 8, 8, 2 as 2 times 4, 4, 1. Okay. Now this 4, 4, 1, I can't divide by 2. So let's try and select another prime number. Let's jump to the next one. Let's try 3. Okay. Let's see if 3 will work. So is it possible to divide 4, 4, 1 by 3? 4 divided by 1 would be 1, remainder 1. Now 14 divided by 3 without going over would be 4, remainder 2. So it's 21 divided by 3, that's 7. So I can divide this by 3. So 3 times 1, 4, 7. Okay. So now let's see if 147 divides by 3. I'm not going to try 2. Let's try 147 divided by 3. So 14 divided by 3 without going over would be 4, remainder 2. So 27 divided by 3, well, 24, yeah, so that would be 9. So I can visualize 147 would be 3 times 49. Okay, 49, I can remember that from my times table. 7 times 7 is 49. So I can visualize this, the 49 as 7 times 7. Now if you look at all these here, these are all primes. 2, 2, 3, 3, 7, 7. So I could write 1764 equals 2. So that's done. Times 2. So that's done. Times 3. Times 3. Times 7 and times 7. Okay. Now, do you see? We've just written this number as a product of primes because all these are primes. All these are primes. So here, once you've written it in this form here, you can find out all the factors you want. So now we can say that 2 is a factor, 3 is a factor, 7 is a factor. Now let's combine these two now. 4 would be a factor. Let's combine this. 2 and 3. So that would be 6. 6 is a factor. Combine 2 and 7. That 14 would be a factor. If you get this divided by 14, it will give you a whole number. You could combine the, I don't know, you could start combining all 3 if you wanted to. 1, 2 here. So that would be 2 times 2 is 4 times 3 would be 12. 12 is another factor. You could combine 7 and a 7. 49 would be another factor. Or maybe a 2, 7, 7. Or a 3, 7, 7. Or maybe a 2, combine it with a 3, combine it with a 3, combine it with a 7, combine it with a 7. So that would be another factor, and so on. But try to work out a systematic way of listing this. You don't want to repeat yourself. So somehow, well, anyway, try to get to a product of primes, and then from that you can find out as many factors as you want. Okay.